So recall that if you have a pair, use sine law, okay? If you have a pair, use sine law, obviously, just talked about it. But there are two cases that you cannot solve with sine law. And I know I don't want the letters, I don't want you to fix on the letters, but if you have angle, angle, side, or you've got side, side, angle, or you've got angle, side, angle, how many cases does sine law cover? 3. So most of the time you'll be using sine law. Okay, that's not abnormal, that's normal. 2 cases, cosine law. Okay? So the first one is side, side, side. You've got all 3 sides given to you. So check mark, check mark, check mark. Or if it's an obtuse angle, doesn't matter. You know all 3 sides. Okay? That's one case. And then the other one is side, angle, side, where you have 2 sides and the angle in between. So side, angle, side, for example, could be happening in this corner. Maybe make an angle, right? Side, angle, side. That's why it's called SAS. Here I do use letters. For cosine law, I like to use the cases for, and then, or you could have this scenario where you have the side length here, it's an obtuse angle there, and the side length there. So again, side, angle, side is there. Okay? In both of these cases, there is no pair, correct? Remember that. Sine law, pair. Cosine law, no pair. That's another way of remembering it. And so here are the formulas. If you do not have pair, we need to use cosine law. Side, angle, side is the 2 sides and the angle sandwiched between. Okay? So I will focus in, I'm going to use a red pen, and for this example, we're going to focus on that side, this angle, and that side over here. Let's say we have a scenario where we have a number for this, we have a number for that, and the angle measure as well. The check marks are going to be numbers, okay? And so this is the formula right here. If you have a red pen, I would strongly suggest you use it. In this scenario, or a marker of some sort, in this scenario, all we can do is solve for the side that's opposite the one angle we are given. So this is what cosine law states, that to find x, we must start with x squared, and that is equal to these 2 sides squared and added. And you're like, this is Pythagorean theorem, right? Not so fast. Minus 2 times c, side c that is, times side y, and all of that times cosine of angle. Which angle do you think? X. So on your study sheet, I would like you to have under cosine law for SAS. So you're going to have cosine law. SAS is one of the cases. This is the formula I would like you to have on there. I will give you the variations, but I don't want you to have them on your study sheet because A, it takes up too much space, and then you might get confused, like, what's happening here? Make sure you look up one more time and check you have everything in the right place. You have a minus there, you have a plus there. Check, because that's a common mistake. It's like, oh, I thought this was all multiplying here, Mr. Dirks. No, there's a minus here. Subtract. Okay. Okay, let's assume for a second we were able to get this side and that side, and we have the angle here, and you would like to solve for C, side C. Guess what your pattern would be? C squared is equal to, what are the other two sides that are given to you? X and y in this case. So you go x squared plus y squared minus 2. If you look at the pattern, what goes in here in these brackets? Earlier we had c squared, y squared, and we put c and y in here, right? So this will be x and y multiplied times cosine of, what side are we solving for? So that this will be capital C. Yeah, these are capitals, yeah, because capitals are used for angles. Yeah. How about this? See, check if you understand. If I asked you, write out the formula to figure out y squared right now, fill in the rest looking at the pattern that we've just determined, what would you put down here? Do it. Do it. And the idea is everything that's to the right of the equal sign is going to be, everything is going to be a number, except for cosine, of course. But we're going to replace everything else with a number. Okay. So y squared is what I'm solving for. I'm assuming I have that angle, and I know these two sides. So cover that up. So you're left with c squared plus x squared. It doesn't matter if you went x then c. It doesn't. Right? Minus 2 times c times x times cosine of angle y, and that's when I use this here. There we go. You got the pattern. Let's practice that right away. Let's go to page, we're going to skip 24, we're going to go straight to 25. SAS examples. Okay, let's assume this is Tuesday. You had a long weekend. You're like, I stayed up late. I watched movies. I forgot all about this, right? I hope that the one thing you remember is like, oh, I need to figure out sine law or cosine law. Only one will work. Does sine law work? Because there's no pair, right? I hope that you remember that. So it must be cosine law. That's like the bare minimum right now. So I'm solving for P, right? So this is SAS. And I know that because I've got a side, I've got the angle that's in between the two sides. Okay? So that's cosine law. Okay, so let's write out the formula. If we wanted to solve for P, make sure you square it. That means that we would, what side is this here? 5 is technically R, because this is a cross R, and this is Q, lowercase. So we would go R squared plus Q squared minus 2 times R times Q times cosine of capital P. Do you need to write out the formula every time? No, you don't. Not like with letters. You can just substitute the numbers if you wish to. So let's substitute this. P squared is equal to 5 squared plus 8 squared. I use round numbers here. 2 times 5 times 8 times cosine of 70 degrees. But these could all be decimals down the road. So this is where this calculator is really handy. You can do this all in one entry. So watch what I do. 5x2 plus 8x2 minus 2 times 5 times 8 times cosine of 70. Close the bracket. Like I enter it all in one shot. Just like that. Please don't use negative like at the very bottom, under the 3, there's a negative. Don't use that one because then you will multiply everything. It's minus. Hit enter. So guess what? What do we do if we just want p? What do we do to both sides? Square root, right? So it'd be the square root of this number right here, 61.63, and that keeps going. So that's not the answer yet. We need to square root it. So you go second x2 to get the square root, then go up, copy, and paste, and you hit enter, and that is your final answer. 7.85. We are in centimeters. So technically, folks, you can do this in 3 lines. If you omit the very first step, this can be solved in 3 lines. Yes?
I was looking at the limit configurations for sine law and cosine law. Why does the cosine law work with all 3 angles?
Like if you have all 3 angles, that's the one triangle we cannot solve. All 3 angles does not work. You need at least one side. Yeah, that's a good point. But all 3 angles we cannot solve. So AAA, we cannot solve. Unsolvable. You need at least one side to go off of. Yeah. We're good? And you would probably think, oh, now we're good. Like he's just going to make us do a bunch of examples. I need to give you the other case, this SSS, right? Side, side, side. So let's go back to 24. And guess what? If you have all 3 sides, what's the only thing you can solve for at this point? An angle of your choice. And that is the frustrating part. Sometimes students don't know which one. And I'll show you. It's actually not that bad. So you need to find an angle. Let's get started here. So let's say, obviously, all 3 of these sides will have a number attached to it. Okay? I'm going to assume we're going to solve for, bless you. I'm going to assume we're going to solve for angle x. So I used the formula that I gave you, but I have rearranged it. So I will do this. Cosine of capital X, right, is equal to, you just make a long line like this. It's going to be, 2 sides are going to be added, but the last one, so it's going to be this plus this minus the one at the end here. And this is the most important one. If you're trying to solve for angle x, you're going to have side x squared and subtracted at the back. And the other 2 sides, which is in this case c and y, in no particular order, they get added, and all of them get squared. Please don't miss that. You square them all. But you add and then you subtract. Okay? And in the denominator, you go 2 times the first side that you were adding times the second side that you were adding. And so x never shows up again, right? Like, so this side back here is the only time it appears. Everything else is just c and y here. So this is your formula for side, side, side. But of course, I'm not just going to let you get away with that, right? What if we wanted to solve for angle C? How would this start? Cosine of C. You're going to go equals, long line. The most important one is back here. You're going to go minus C squared, that's right. And what goes on the front here? Cover up the side you used here. It's x and y that is left over. like that. So this squared plus this squared minus that squared. And in the denominator, you're going to go 2 times x times y. That's the formula for C. You think you can do, what's the other angle we can solve for? Y, right? Reflexes. This would be minus y squared, because you're trying to solve for angle y. Therefore, this side has to be subtracted and squared, and you're left with c squared plus x squared. And then at the denominator is 2 times c times x. And there you have it. So I hope you see the pattern. Oops. That's cosine law in a nutshell. This allows you to solve for an angle. The other one allows you to solve for a side. Let's put it into practice, okay? Let's go over to, I'm going to skip, no, I know what I'm doing here. Trust me, I know what I'm doing. Go to 25. I'm almost done. Now that we have P, we technically have side, 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 correct? But do we also have a pair? Could you use sine law? But today we're going to assume like we can't. We're just going to be like we're stuck with side, side, side. We want to solve for angle R, let's say. Okay, so I will make a note. Now we have a side, side, side case. So I'll just make a quick sketch. This is P, Q, R, 5, 8, 7.85. Just a quick sketch. And I know that this is 70, right? But I'm going to ignore it for now. We don't know that's there. Okay? Side, side, side. So if you wanted to solve for R, we would go what? Cosine of R, long line. R squared would go at the back here, subtracting. And we know that this is Q and this is P. Okay? So this would be P squared plus Q squared over 2 times P times Q. Let's substitute in. P is 7.85. Let's square that. Q is 8. Let's square that. R is 5. Let's square that. Divided by 2 times 7.85, which is P, times Q, which is 8. And now you want to be careful. You cannot do this in one shot. I would not recommend it, at least. You can, but let's type in the top 7.85 squared plus 8 squared minus 5 squared. Put that number down with all decimals. 100.6225. All decimals, okay? Then it's 2 times 7.85 times 8. That's 125.6. We're going to go here and say cosine of R is whatever we get when we divide these two. So just divide them on your calculator. So you go top, divide it by bottom. You get 0.8011 something. What are we going to do just before we find the angle? Inverse. That's right, inverse. So angle R is cosine inverse of 0.8011 something. So guess what I'm going to do on my calculator? Just like with sine law, I went second, and now I'm going to press cosine. As such, you got to do every time. If you want to find an angle, you got to use inverse. So angle R is 36.76 degrees. Okay? How do I find angle Q now? Let's do that right here. Cosine of Q. I'm going to skip the letters, okay? What I need to make sure is if Q is what I want, then I go 8 squared here. This is 5 squared plus 7.85 squared. Mr. Dirksen, why don't you just use sum of 180? I know. I know I can use it. I just want you to practice this. So let's type that in. The top gives me 22.6225. The denominator is 78.5. You divide these two. That's 0.288 something. Last step is angle Q is cosine inverse of 0.288 something. And here it is. 73.25 degrees. Okay, so we've practiced how to use side, side, side there. All right. I want you to try that. So I'm going to assign $26 to $29. $26 to $29. This is all cosine law, okay? You still got about 9 minutes if you want to get started on it. It's probably a good idea.